Hi everyone, so today we'll be talking about the digestive system. This includes the upper GI tract, the intestines, as well as the accessory organs. So let's give an overview of the digestive system. Functions are digesting food, absorbing nutrients, and removing waste. So we start off with our mouths chewing the food, and then the saliva turns it into a bolus. The bolus of food then travels down our pharynx and then to the esophagus, and then the esophagus passes through the esophageal hiatus and the diaphragm to enter the abdomen. The esophagus joins the stomach, right? And after that, the food gets to the duodenum, and then the small intestine, the large intestine, the rectum, and later waste is excreted by the anus. The upper GI tract consists of the esophagus, the stomach, and the duodenum. So a hint is Amyloides dinosaurs. There are also three main blood vessels that supply the abdomen. This includes the celiac trunk, the superior mesenteric artery, and the inferior mesenteric artery. So another mnemonic is Carly stays inside. The superior mesenteric artery supplies the midgut and includes the small intestine, the appendix, the ascending colon, and the proximal two-thirds of the large intestine. The inferior mesenteric artery supplies the hindgut, the distal third of the transverse colon, the splanchnic flexure, the descending colon, the sigmoid colon, and the rectum. The celiac trunk supplies the embryonic foregut to the upper parts of the abdomen. This includes the liver, stomach, esophagus, pancreas, duodenum, and the spleen. Okay? The celiac trunk also has three more branches. So these are the left gastric artery, the splenic artery, and the common hepatic artery. So another mnemonic, love salty popcorn. Now let's talk about the venous drainage. All of the veins from the GI tract, the pancreas, the spleen, and the gallbladder will drain into the hepatic portal vein, which takes blood to the liver. This process allows the nutrients to be extracted, and one common example is glucose that's stored as glycogen. Okay? So esophagus. So when examining the esophagus, it is divided into two parts, the thoracic esophagus and the abdominal esophagus, which is below the diaphragm. The arterial supply of the abdominal esophagus is the branches of the left gastric artery, the left inferior phrenic artery. So something that I like to remember is left gas and pain. So left gastric and then inferior phrenic. And then the venous drainage. So the thoracic esophagus has esophageal veins, and then those drain into the azygous venous vein. Whereas in the abdominal esophagus, it's the left gastric vein, which drains into the portal venous system. It's a key contrast. Now, let's talk about the lymphatic drainage of the esophagus. Okay, we have the thoracic esophagus, particularly, and so the superior part of this esophagus it's going to drain into the jugular trunks. The mid part is going to drain into the bronchomediastinal trunks of the chest, and the lowest part is going to drain into the superior diaphragmatic nodes and then into the trunks. The abdominal esophagus is going to drain into the celiac or abdominal lymph nodes. Innervation. So the parasympathetic innervation involves the posterior and anterior vagal trunks. The sympathetic innervation involves the thoracic sympathetic trunk, which innervates the greater splanchnic nerve. Mixed innervation, so innervation of both the sympathetic and parasympathetic supply, include the periarterial plexuses around the left gastric artery and the left inferior phrenic artery. Note that the mixed sympathetic and parasympathetic supply is going to be around the arterial blood supply to a specific structure to ensure that vasoconstriction and vasodilation is maintained and controlled. Now let's move on to the stomach. After the esophagus, we have the stomach. The stomach consists of the Z-line, which is the transition between the esophageal mucosa and the gastric mucosa. So the parts of the stomach include friends can't break promises. So that's a hint. So this stands for fundus, cardiac notch, body, and pylorus. Okay? Pylorus has two funnel types, the pyloric antrum, which is a wide chamber, and the pyloric canal, which is a narrow chamber. Inside the stomach, we have the rugae, which are gastric folds, as well as the gastric canal. So now let's do a compare and contrast of the stomach, particularly the lesser and greater curvature, as you can see right here and here. So the lesser curvature has the gastric canal forming along the lesser. So the gastric canal forms along the lesser curvature, supplied by the right and left gastric veins, formed by the anastomoses of the left and right gastric arteries, consists of the gastric lymph nodes, and blood supply will be the right and left gastric arteries. Okay. The greater curvature, rug A, is mostly found here. So it's supplied by the right and left gastromental veins, as well as it's supplied by the anastomoses of the left and right gastromental arteries, and it consists of the gastromental lymph nodes. Blood supply will be the right and left gastromental arteries. Both the stomach and both parts of the stomach are the lesser and greater curvature, so that's a similarity, and all the gastric veins will drain into the hepatic portal vein. The lymph node correlates with the arteries as well. Okay. So now let's talk about the innervation of the stomach. So parasympathetic innervation has both the anterior and posterior vagal trunks. The anterior vagal trunk is formed by the left vagus nerve, and the posterior vagal trunk is formed by the right vagus nerve. Sympathetic innervation includes the 3 splanchnic nerves, so greater, less, and the least. And then we also have to note that the greater splanchnic nerve connects with the celiac plexus, which will give sympathetic supply to the stomach. Mixed innervation, so it's important to note that mixed innervations are always going to be around blood vessels that supply the organ. So for the stomach, this includes the periarterial plexuses around the gastric and the gastromental arteries. Now let's talk about the duodenum. So the duodenum is actually separate from the stomach, okay? And it's not part of the stomach. It's actually part of the small intestine, and it rotates and elongates as it forms, and as a result, it gets a sympathetic innervation from the 2 plexuses. Blood supply will come from both the celiac trunk and the mesenteric artery. The more superior part of the duodenum is supplied by the branches of the celiac trunk, which include the gastroduodenal artery. These arteries also give branch to the superior pancreaticoduodenal artery. The distal part of the duodenum is supplied by the inferior pancreaticoduodenal artery, which is a branch of the superior mesenteric artery. So to summarize that up, the duodenum is supplied by both the superior and inferior pancreaticoduodenal arteries. And note that the celiac trunk is superior to the superior mesenteric artery. For venous drainage, I have created this flowchart which outlines the superior pancreaticoduodenal artery, the inferior pancreaticoduodenal vein, and the superior pancreaticoduodenal vein, all joining to form the hepatic portal vein. Okay. Now let's talk about the lymphatic drainage. So the pancreaticoduodenal lymph nodes will drain the duodenum. The duodenum is supplied by the pancreaticoduodenal arteries, veins, and lymph nodes. Pyloric lymph nodes also supply the duodenum. The distal part of the duodenum is drained by the superior mesenteric lymph nodes. And innervation of the duodenum. So we have the sympathetic and parasympathetic innervation. So parasympathetic includes the anterior and posterior vagal trunks. Sympathetic is the celiac plexus and the superior mesenteric plexus. Note that the celiac plexus is innervated by the greater splanchnic nerve, whereas the superior mesenteric plexus is innervated by the lesser splanchnic nerve. For mixed innervation, this includes the periarterial plexuses around the pancreaticoduodenal arteries. So one of the key messages that is important to note here is that the duodenum is unique in the sense that it gets its blood supply from 2 of the major abdominal vessels and 2 of the plexuses. Now let's move on to the small and large intestines. We'll start off with the small intestines. Small intestines include the duodenum, the jejunum, and the ileum. So hint, DJ India. The ileum is the longest part of the small intestine, and it ends at the ileocecal junction, as you can see in the image. And that's where the large intestine begins. The jejunum begins at the duodenal junction and is the middle portion of the small intestine. The small intestine is also held in place by the mesentery, which is a double-folded peritoneum, which attaches the intestines to the posterior abdominal wall so that they're held in place. Okay? It's also important to note that the superior mesenteric artery supplies the structures on the right side of the abdomen. So I came up with the word association, Superman, right? Superman is always right. And then inferior mesenteric artery supplies the left side of the abdomen. So left, villain feeling inferior. There's also vasa recta, okay? Vasa recta directly supply the small intestine, and they're straight arteries that come off of the arterial arcades. So once the nutrients are absorbed by the small intestine, they go to the superior mesenteric vein, the hepatic portal vein, which then directly goes to the liver. Liver will remove some of the nutrients and store them. Note that the venous drainage is by the superior mesenteric vein and the splenic vein, which will combine to form the hepatic portal vein, as you can see in the flow chart. It's also important to note that fat-soluble vitamins like vitamin K, E, D, A will not be absorbed by the superior mesenteric vein. Instead, there's going to be lacteals that will absorb them. So lacteals are specialized intestinal villi which will absorb fats and fat-soluble vitamins. And so the lacteals will connect with the intestinal trunks and then to the thoracic ducts. Now, parasympathetic supply of the small intestine is the vagus nerve. Okay, sympathetic supply is going to be dual sympathetic ganglia. Okay, so it's going to be the celiac plexus and the superior mesenteric plexus, which will innervate that small intestine. So another mnemonic that I came up with is skills create success. For the jejunum and the ilium, there's going to be mixed innervation. So this includes the periarterial plexuses, which surround the ileocolic, the middle colic, and the right colic arteries. It's also important to note about sensory or visceral afferent fibers, which give sensation in the small intestines. The general visceral afferent fibers accompany sympathetic motor fibers, which aren't really good at localizing pain. So the small intestine is very insensitive to burning or cutting, but it is sensitive to gas and colic ischemia. Pain impulses travel from the splanchnic nerve to the sympathetic trunk. Once the pain impulses are in the posterior great column of the spinal cord, the general visceral afferent fibers activate the general somatic afferent fibers, which causes referred pain. So that's why sometimes you may have back pain as a result of something wrong with the small intestines. Now let's talk about the large intestine. So we have the cecum with the appendix attached on the right side, okay, and the colon. So we have the ascending, transverse, and the sigmoid colon, as well as the rectum and the anal canal. So this is an mnemonic that I came up with. Creepy Cinderella avoided Tinkerbell's shoes, rings, animals, to help me remember the parts of the large intestine. Further examining the intestine, we have the tenai coli, which are longitudinal thickened bands of muscle. We have the caliber, which means large diameter. We have haustra, which are pouches, and then omental appendices, which are small fatty appendices. So another hint, tigers clawed heartless oysters. Now let's talk about the supply of the large intestine. So we have the parasympathetic supply, which is a vagus nerve, and the sympathetic supply, which is a lesser splanchnic nerve and the superior mesenteric plexus. Okay. Note that the right side of the large intestine is supplied by the superior mesenteric artery, and the cecum is supplied by the branches of the ileocolic artery, which gives rise to the appendicular artery, which supplies the appendic. Okay. When examining this large intestine, the ileocolic vein will also drain the cecum, and the appendicular vein will drain the appendix. The ileocolic valve is like a sphincter in between the end of the small intestine and beginning of the large intestine. I also want to come back to the sympathetic supply, and it's an important contrast to make that this is different. So the large intestine's sympathetic supply includes only the lesser splanchnic nerve and the superior mesenteric plexus, but the small intestine had dual innervation, right? The dual sympathetic ganglia. Yes, and so yeah. Now let's talk about the ascending colon. This includes the arterial supply, which is the ileocolic artery and the right colic artery. The venous drainage is the ileocolic and right colic veins into the superior mesenteric vein. Another important detail is that the right colic flexure is a bend between the ascending and transverse colon. Sympathetic supply is the lesser splanchnic nerve and the superior mesenteric plexus, and the parasympathetic supply is going to be the vagus nerve. For the transverse colon, it runs from the right colic flexure to the left colic flexure. It's supplied by the superior mesenteric artery. The right colic and left colic arteries also supply the transverse colon through anastomoses, which are connections between the blood vessels. Okay. When we're examining venous drainage, this is actually going to be the middle, left, and right colic veins, which will drain into the superior mesenteric vein. Sympathetic supply, inferior mesenteric plexus, and for mixed innervation, it's going to be the parietal plexuses around the blood vessels that supply the transverse colon. This includes the parietal plexuses on the right colic, the middle colic, and left colic arteries. Now let's talk about the descending colon. Okay, so we have the inferior mesenteric muscle, the superior sigmoid artery, which is supplied, which supplies the descending colon, as well as the left colic artery. So another hint: insects scare lions. So here's a big, large image of the large intestine, and I want to particularly focus on the sigmoid colon here because it has a lot of arteries. So the sigmoid colon is supplied by the sigmoid artery, which are branches of the inferior mesenteric artery. So the venous drainage for both the descending colon and the sigmoid colon include the inferior mesenteric vein, which drains into the splenic vein, which drains into the hepatic portal vein. Parasympathetic supply for the sigmoid and descending colon is the pelvic splanchnic nerve, which drains into the inferior hypogastric plexus. Sympathetic supply is from the lumbar splanchnic nerve, so L1 and L2, as well as the inferior mesenteric ganglion. Another important message is that the descending and sigmoid colon have different parasympathetic and sympathetic supply from the rest of the small and large intestines. Mixed innervations for both transverse and sigmoid colon include the periarterial plexuses around the left colic and sigmoid arteries. Now let's talk about the collateral circulation. We have a marginal artery, which supplies the collateral circulation to the small intestine and is an anastomose of all of these arteries. Okay, so a hint: ice rises, melts, leaks, spills, which summarizes these arteries. Now let's move on to the accessory organs. We have the spleen, which is found on the left side of the upper abdomen. Okay, so the spleen also has peritoneum, which surrounds the spleen except at the hilum. At the hilum is where the splenic branches of the splenic artery enter and leave. This is also where the splenic vein enters and leaves. We also have a splenorenal ligament, which connects the spleen to the left kidney, as well as the gastrosplenic ligament, which connects the spleen to the posterior wall of the greater curvature. So blood supply. So the splenic artery distributes the blood to the organ which branches from the celiac trunk. The nerve supply of the spleen is the celiac plexus. The effect would be vasomotor, which controls the size of the splenic artery. Venous drainage is from the splenic vein, which will join to form the inferior mesenteric vein and then combine with the superior mesenteric vein to form the hepatic portal vein, as outlined in this flow chart. Now let's move on to the pancreas. Okay, we have two pancreatic ducts, the main pancreatic duct as well as the accessory pancreatic duct. The accessory pancreatic duct travels straight through the pancreas, whereas the main pancreatic duct starts at the tail and travels downwards towards the head of the pancreas and merges with the bile ducts. Note that when the bile and pancreatic duct join, they form something called a dilated hepatopancreatic ampulla, which opens at the major duodenal papilla. So here are the parts of the pancreas. We have the body and the tail. Okay, those are supplied by the splenic artery, as well as the head of the pancreas, which is supplied by the pancreaticoduodenal and posterior superior pancreaticoduodenal arteries, anterior inferior pancreaticoduodenal, and posterior inferior pancreaticoduodenal arteries as well. So a hint: big tigers hunt under noon. Okay, we have the unicip process as well as the neck. Now let's talk about the venous drainage. So the venous drainage is by the superior and inferior pancreaticoduodenal veins, which will drain into the splenic and superior mesenteric vein. Note that most of the pancreatic veins will drain into the splenic vein. Okay, so parasympathetic supply is the vagus nerve. Sympathetic supply is the greater splanchnic nerve which innervates the celiac plexus. So I like to remember guanine and cytosine. So greater, G, and then celiac is C, so they're together. And then venous drainage is the splenic vein. It's also important to note that the lesser splanchnic nerve innervates the superior mesenteric plexus. Okay? And for sympathetic supply, note that the pancreas also have a dual sympathetic innervation like the small intestine. So that's an important comparison to make. Now let's move on to the liver. So the visceral surface of the liver is covered with peritoneum, except at the bed of the gallbladder, which consists of the gallbladder, and the portal hepatis, which contains the portal triad. A key message to note is that the bare area is not covered with the peritoneum and is part of the liver that lies in contact with the diaphragm. So I like to remember the location of the bare area by thinking about a bear. Imagine a bear and you see one and you start breathing, right? Your diaphragm moves up and down. So that's how I like to remember the bare area, that it's located close to the diaphragm, okay? And porta hepatis consists of the portal triad, which contains the hepatic portal vein. The triad also contains the hepatic artery, which brings blood to the liver, and common hepatic duct, which brings bile from the liver. Okay? The liver consists of 4 lobes. This includes the right, the left, the caudate, and the quadrate lobes. Okay? Note that the right lobe is larger than the left lobe as well. And here is a comparison and contrast. So the right and left lobes are anatomical structures. They're separated by a falciform ligament, and a falciform ligament attaches to the liver to the interior abdominal wall. Whereas the right and left livers, they're physiological concepts. So I'm just comparing, contrasting that. And the right liver is supplied by the right hepatic artery, and left liver is supplied by the left hepatic artery. So essentially, the whole liver is the blood supply the main blood supply is the hepatic artery from the celiac trunk. Okay, innervation of the liver. So one important detail that I'd also like to add is that there's a round ligament and a ligamentum venosum, which are fetal remnants of the liver. Now let's move on to the blood supply. So we know it's the hepatic artery. At the porta hepatis, the hepatic artery will divide into the left and right branches. The hepatic branches will further divide into secondary and tertiary branches and form hepatic segments. Between the hepatic segments are the right, left, and middle hepatic veins. Note that there's 3 hepatic veins, but 2 hepatic arteries. The hepatic veins will then drain into the inferior vena cava. Okay? So the sympathetic supply is the celiac plexus. The parasympathetic supply is from the anterior and posterior vagal trunks. So the vagal trunks and the celiac plexus lead to the hepatic plexus, which is the mixed innervation. Now let's talk about the gallbladder. This is the fundus, the body, and the neck. Okay, has those 3 parts, and the neck connects with the cystic duct. So a way that I like to remember is use an mnemonic: fried bean noodles. Okay. So let's go back to the liver first. It's important to note that the liver produces bile, but the gallbladder stores it and concentrates it. So the bile leaves through the left and right hepatic ducts, which will then join to form the common hepatic duct. The bile duct joins the main pancreatic duct at the hepatopancreatic ampulla. Another important key point I want to distinguish is ducts versus blood vessels. Okay? So I want to contrast about ducts and blood vessels. So ducts are actually wider and curvier compared to blood vessels, which are straighter and narrower. Okay, now let's talk about the drainage. So the venous drainage, so the neck and bile ducts of the gallbladder drain into the cystic veins and then into the hepatic portal vein. The veins from the fundus and the body of the gallbladder will drain into the hepatic sinusoids. For the arterial supply, it's supplied with the cystic artery. Sympathetic supply is through the cardiac plexus, and then the vagus nerve is responsible for the parasympathetic supply. Now let's look at some clinical studies to apply our learning. Okay, so Jimmy had mid-back pain for a 3-week duration. So he went to the chiropractor and the treatments provided brief pain relief. Okay. He began to experience appetite loss though, and then nausea and vomiting after. He noticed his eyes and his skin becoming yellow, and he went to the ER, and the ER physician asked if there was any change in bowel movements. The patient noted that his stool had become pale and it floated. He also experienced foul-smelling diarrhea. On examination, the ER physician palpated an enlarged gallbladder, and preliminary blood work showed diabetes. So what is wrong with Jimmy? Well, I have highlighted all of the important stuff, right, in red. And something that really speaks to me is jaundice. Because of the yellowing skin and the eyes, that indicates something's wrong with the liver. And it is jaundice from bilirubin accumulation in the blood. So we know the liver is involved. The gallbladder is enlarged, so that's not normal. And then the pancreas are also involved in this case because something's wrong with them. It shows diabetes, so that means that insulin isn't being produced properly in the pancreas. And a key point is stool floating. Okay, if we recall, we know the lacteals are intestinal villi that absorb the fats and fat-soluble vitamins, but that's not happening here, right? And it's also because of pancreas making lipase to break down the fat. So because the stool is floating, that means the pancreas aren't doing their job. Okay. And now we also have the enlarged gallbladder. So the doctor orders more tests, like an ultrasound, as well as which found actually masses, abnormal masses. And so as a result, a biopsy was performed and it showed cancer, pancreatic cancer. And so that's why the enlarged gallbladder was present, is because the pancreatic cancer was blocking the bile duct. Now, Valerie is another clinical case study. She has pain in the middle and upper part of the abdomen, so the epigastric area. She also has pain at the right shoulder. So she goes to her doctor, who diagnoses her with having gallstones. So here I have an image of the gallbladder with gallstones. Now, how can this be? How can you get pain in your right shoulder and realize it's gallstones? Well, we need to consider the anatomical structure surrounding the liver, which is the peritoneum, as you may recall. Okay? The anatomical structure above the liver is the diaphragm. So we need to think about the nerve. So in this case, the phrenic nerve supplies the diaphragm, but it's also important to note that the phrenic nerve comes from the spinal levels C3 to C5 roots, okay? And so the C3 to C5 roots supply the shoulder as well. And so because it's coming from the phrenic nerve, the somatosensory cortex is going to interpret that signal as coming from the right shoulder. And that's why Valerie has right shoulder pain, because that's what the body's interpreting. Now, I hope you learned something from this presentation, and I'll see you next time.